Hello students, I am teacher Justin and this is the introductory lesson on the Abacus course. So throughout the course, we will learn about how we can use Abacus and mental math to work out difficult sums with ease. So let's jump straight into it. So today we will be going through 4 chapters about Abacus and then I'll guide you through some example questions in the worksheet. So first thing, let's go through the history of the Abacus together. Do you know what an abacus is and what it is used for? An abacus is an ancient arithmetic instrument that is still in use today. It was used widely in parts of Europe, China, Russia, and many other civilizations centuries before the adoption of the written Arabic numeral system. Here is some information about the various abacuses around the world in the past. You can pause the video to read up on your own. So for comparison, this is how the Chinese swanpan, Japanese soroban, and the Russian shorter looks like. If you examine the various abacuses carefully, you can tell that the Japanese and Chinese abacuses are divided into 2 segments, top and bottom. The Chinese abacus has 2 top row beads and 5 bottom row beads. The Japanese abacus, however, has 1 top row bead and 5 bottom row beads. The modernized Japanese abacus, however, has 4 bottom row beads instead. The Russian abacus is quite different, as you can see, and it has rows of 10 beads. For these abacus lessons, we will be using the modern Japanese version with 1 top row bead and 4 bottom row beads. It is the most efficient abacus out of the 4. So here are some more pictures of ancient abacuses for your viewing pleasure. Next, I will be introducing the parts of an abacus to you. So this is an online modernized Japanese abacus which we will be using for the following lessons. Like I mentioned previously, in the modern abacus, there's 1 top row consisting of counters or beads with a value of 5. There are also 4 bottom rows consisting of beads with a value of 1 each. So in addition, you may have noticed that there is a crossbar that divides the abacus into 2 sections, the upper section and the lower section. There are also several columns, each representing different digit places. So for example, as we move from the right side of the abacus to the left, we increase the digits place value by 1. So we go from ones, tens, to hundreds, to thousands, and so on. This concept is very important for further calculations. And with that said, now we will be learning about identifying several numbers. So this is the default position of the abacus with all the 5 beads pushed up and all the 1 beads pushed down. So note that none of the beads are in contact with the crossbar. Because of that, the value shown in the default position of the abacus is 0. We should always aim to reset our abacus to this position after we are done with a whole calculation sum. So this is called clearing the abacus. So in the next picture, you can see that the abacus is slightly different. On the rightmost column, one of the bottom row beads is pushed up and is now touching the crossbar. So when we are counting numbers on the abacus, we only count the number of beads that are touching the crossbar in the center over here. So remember that the value of the bottom row beads is 1 each, and we call them 1 beads. Over here, one of the 1 beads is pushed up. So therefore, the value of the abacus is 1. So with that in mind, how do we depict the number 2 in our abacus? For the number 1, we have pushed up 1 of the 1 beads. And so, for number 2, we have to push up 2 of the 1 beads. Over here, you can see that 2 of the 1 beads are pushed up and is now touching the crossbar. So this is the same for number 3. As you can see, I have pushed up 3 of the 1 beads. The value that is touching the crossbar over here is 3. Now, can you guess how does the number 4 on the abacus look like? That's right. To get a value of 4, I have to push up 4 1 beads upwards so that they are touching the crossbar. Notice that when we add 1 to the current number, the number of bottom beads that are in contact with the crossbar increases by 1 too. However, how do we get to number 5? There are only 4 bottom row beads. So recall that we have 5 beads, which are the beads at the topmost row of the abacus. It is time to make use of that. So let's do a recap by counting to 4. Over here, we have the default position of the abacus that is showing a value of 0. I will use the rightmost column over here for this demonstration. To get 1, I can push this 1 bead over here upwards. To get the number 2, I simply add a bit by pushing another bit upwards. To get number 3, I'll push another bit up, and finally to get number 4, I'll push this last bit over here upwards. This is where the tricky part is. We do not have enough 1 bits or bottom row bits to make the number 5. Therefore, I'll make use of the bit on top over here, which is known as a 5 bit. This top row bit has a value of 5. Now, let me reset this column to 0 and then add a 5 bit by pushing it down. And here we have the number 5. Do note that we have to push all the 1 bits back down. As you can see here, if I simply add 5 on top of the current 4, I'll get a value of 9. So this is not what we want. We must make sure to reset the calculator or reset the column before pushing down the 5 bit to get the number 5. Okay, so as seen just now, this is how the number 5 looks like on the abacus. One 5 bit is pushed down and there are no 1 bits that are pushed upwards. Because the only bit touching the crossbar is the 5 bit, we can tell that this number is 5. Then, how do we turn the number 5 into number 6? 6 is 1 more than 5. So we can add 1 to 5 to make 6. We can do this by adding a 1 bit to the 5 bit. Because 1 5 bit and 1 1 bit is touching the crossbar, we have 5 plus 1, which gives us 6 in total. Naturally, if we want to depict 7 on the abacus, we can add 1 to the number 6 or 2 to the number 5. Both will give us the same result. As compared to 6, number 7 has 1 more 1 bit pushed up to the crossbar. As you can see over here, there are 2 1 bits being pushed up. So therefore, to make a 7, we need 1 5 bit and 2 1 bits. 5 plus 2 gives us 7. Moving on, we have the number 8. As you can see, 8 is simply 3 1 bits pushed up and 1 5 bit pushed down, because 3 plus 5 gives us 8. And as for 9, we simply add 1 more 1 bit to 8, and then we have 9. 9 comprises 1 5 bit and 4 1 bits. Now that we are done learning about numbers from 1 to 9, let's look at bigger numbers. Let me introduce you to the concept of digit placements in the abacus. So here's a little exercise for you. Can you spot the difference between the 3 diagrams? In each abacus, there is 1 1 bit pushed up, but they are at different places. Where is that 1 bit located on each of the abacuses? And what value does that give you? Pause the video to try and figure out the answer. The abacus on the top left has a 1 bit in the second column from the right. That gives us a value of 10. The abacus on the top right has a 1 bit on the third column from the right. That gives us a value of 100. Finally, the third abacus at the bottom has a 1 bit in the fourth column from the right. That gives us a value of 1000. Did you manage to spot the pattern? The further away the columns are from the rightmost column, the value of the number increases. This happens because the columns represent different digit places. Just like if I write out a number on a piece of paper, the digits increase as I move to the left, from ones to tens to hundreds and finally to thousands, and so on. The same applies to the abacus. In this diagram, we can see that each column in the abacus actually represents a separate digit place. The one on the right over here is the ones column. The one next to it is the tens column. The one on the left of the tens column over here is the hundreds column. And finally, the one on the left of the hundreds column is called the thousands column. Of course, we can go on and talk about the 10,000s column and the 100,000s column as long as there are enough columns on the abacus, of course. Now, let me go through some examples of counting numbers. Please rewind the video and refer to the previous slides if you cannot remember the digit placements of the abacus. Over here in this abacus, in the thousands place, we have an 8. 5 plus 3 1 bits gives us a value of 8. In the hundreds place, there is a number 5. We have 1 5 bit that's pushed down and is touching the crossbar now. In the tens place, we have a 4. 1, 2, 3, 4 1 bits gives us a number 4. Lastly, in the ones column or the ones place, there is a 7. One 5 beat and two 1 beats gives us a value of 7. Therefore, the number is 8547 or 8547. You can refer back to the previous slides to revise the topic on counting numbers from 1 to 9. As you can see, the columns on the left of the number 8 are zeros and can be ignored in our calculations. This is because you have learnt in school that any zeros that come before a number can actually be ignored because they give the same number. In this case, 0.00008547 is the same as 8547 in short. Moving on, we have the number 1523. Reading the abacus from left to right, we have 1000 over here, 500s, 2 10s, and 3 1s. Therefore, this number is 1523. The simple reason we read the abacus from left to right is because when we say out a number verbally, we say the largest digit first. For example, in 1523, notice how it is natural for all of us to say out 1000 first and then followed by 500. This is because 1000 is a larger digit than 100. So if I say out the larger digits first, I must also similarly read the abacus from left to right, because the larger digits always occur on the left of the abacus. So lastly, I have here the number 3010. There is a 3 in the thousands place over here, a 0 in the hundreds place, a 1 in the tens place, and a 0 in the ones place. Notice that I've counted the zeros in the hundreds place and in the ones place. I have to count the zeros whenever it is between two non-zero digits, like over here 3 and 1, or when it is on the right of another number like the number 1 on this case, I have to count the 0 here. This is because if I don't count the zeros in 3010, the number becomes 31, which is another number entirely. Therefore, the lesson here is that I must count the zeros that are important to the number. A quick rule for remembering that is any zero on the right hand side of the first non-zero digit should be counted. Let me explain this in more detail. So for example, can you guess what this number is? The answer is, it is 700,000. This is because I omit or ignore the zeros on the left hand side of the 7, and 7 becomes the first non-zero digit I have here in the abacus. Therefore, the columns that I have circled over here contain the numbers that are important to the number. This means if I ignore any of the zeros in these 5 columns, this over here will be a different number. Therefore, always take into account the zeros on the right hand side of the first non-zero digit, which is 7, and remember to read the abacus from left to right. We have come to the end of the lesson. If there are still any uncertainties, please feel free to rewind the video or screenshot your questions and upload them into the consultation folder in your own Google Drive. There is also a worksheet that I've uploaded. This needs to be done by the Wednesday of the next week. I will be going through some example questions in the worksheet. The rest have to be done on your own. Thank you, and we will now move on to the practice questions. So in this part of the video, I will be going through some of the example questions found in worksheet 1. The first question, the abacus has a 5 beat push down on the rod 4 from the right. What number is this abacus showing? So let's analyze the question. When they are saying the rod 4 from the right, we know that this is the thousands rod. Why is this so? Let's count from the right. The first rod is the ones column, second rod is the tens column, the third rod is the hundreds column, and the fourth rod is the thousands column. So over here, the question wants us to push down a 5 beat over here. And therefore, if we push down a 5 beat in the thousands column, it will give us a value of 5,000. That's pretty simple. So let's reset the abacus for the next question. In example question 1, the abacus has a 5 beat push down and two 1 beats pushed up on the rod third from the right. What number is the abacus showing? So the rod third from the right is the hundredths rod. We have one 5-beat push down and two 1-beats, 1, 2 pushed up. This abacus is showing the number 700. In example question 2, send a screenshot of the abacus simulator depicting the number 7698. So for the purposes of this demonstration, I will not be sending a screenshot. Instead, you can view the answers directly on the screen here. So let us break down this question or this number into several parts. We have 7 thousands, 6 hundredths, 9 tenths, and 8 ones. So over here, starting from the left, we know that this is the thousands column. We have number 7, push down 1 5, and we push up 2 1-beats. Next, we have 6 hundredths. 6 is comprised of 5 and 1, so we push down 1 5-beat and 1 1-beat. Next, in the tens column, we have the number 9, so we push down 1 5-beat and 4 1-beats. 5 plus 4 is 9. Next, we have an 8 in the ones column. 1 5 and 3 ones make up 8, so this is 7,698. Let me reset the abacus for the next question. So in example number 3, send a screenshot of the abacus simulator depicting the number 1, 2, 4, 3. So this is quite easy. All the numbers over here are below number 5. So we can just count the 1-beats. 1, 2, 4, 3. Easy. For example question 4, send a screenshot of the abacus simulator depicting the number 5012. So we must remember that the 0 in between 5 and 1 is an important 0 to the number, means we cannot ignore it. Similarly, we have 5 thousands. Over here, the thousands column, I have 1 5-beat push down. And in the hundreds column, I don't push down anything because it is the number 0. In the number 0, none of the 5 beats and 1 beats are touching the crossbar over here. So we leave this column empty. Next, we move on to the tens column. The tens column has a value of 1, so we push up 1 1-beat. In the ones column, we have a value of 2, so we push up 1 2 1-beats. This is 5012. Next, example question 5. We need to depict the number 578. So this is quite easy, but do take note that this number is only 3 digits, unlike the 4-digit numbers that we have done previously. So this should be quite easy as well. However, we must start from the hundreds column now, because 578, there is no thousands digit over here. So in the hundreds column, we have 5, and then in the tens column, we have 7, 1 5 and 2 ones, and in the ones column, we have the number 8, 1 5 6 7 and 8, and there we have 578. Moving on to one of the more challenging questions. Question 16, part A. For the following pictures, write their corresponding number in the grid below. Over here, let us count from the left to the right again. In the hundred thousands column, we have the number 1. In the 10,000s column, we have the number 2. In the thousands column, we have the number 5. In the hundreds column, we have the number 3. In the tens column, we have the number 7, and in the ones column, we have the number 4. Therefore, this number is 125,374. So we have come to the end of this tutorial. Thank you for watching.